Hello, everyone. This is Ron Gerber of Angel Beat. I'm so excited to have Lorraine Bassett, the worldwide IoT strategist for AWS, talk about IoT, the Internet of Things, and how this technology is finally ready to help organizations, real estate firms, facility managers, college campuses achieve all the benefits of smart buildings. There's so much incredible energy waste, cost inefficiencies, operational challenges that smart buildings can theoretically resolve. But now I'm going to turn it over right now to Lorraine, who's going to share with you how AWS, through its IoT platforms, can help make smart buildings a reality for organizations of all sizes. All yours, Lorraine.
Thank you, Ron. And welcome everybody to IoT and Smart Buildings presentation. So we begin, the focus of our presentation today is really around the Internet of Things and how we can add value to creating what we call smart buildings today. And we begin all of our presentations and our discussions around IoT with, if you knew the state of everything and could reason on top of that data, what problems would you solve? And what we're finding today with regard to smart buildings is this is a new situation. So while we're talking about what problems would we solve, really, I'd like to add another line to that, which is, how do we want to create our futures and how we work with buildings in the future? And what do I mean by that? So let's start with what we mean by a smart building. So buildings, smart buildings could range from schools, homes, assisted living complexes, or corporate offices. And regardless what type of buildings, each one will have a structure and does have some kind of structure today that uses an automated process to control its operations, such as heating, security, and air conditioning. So how's that possible today? So there are sensors, actuators, and microchips installed within buildings that collect data and make it visible so the operators and facility managers can act upon it. And that is being done today, but at a very basic way. So, but the advantages of a really smart building today is that we want to be able to improve the reliability of all of the assets within the building, and we want to be able to improve how it performs from a customer service perspective. So really from the basic HVAC, the air conditioning systems, to water systems, to lighting, which in turn reduces energy and resource use. So what we want to be able to do is positively impact costs and the environmental impact of buildings. And again, it isn't just about what problems would we solve. This is around how do we shift the way we see buildings today and turn them into effective operational assets for our customers. So in the previous slide, I mentioned that there's a smart building. The smart building has a structure, and we have an automated process, or can have an automated process to control its operations. So there are really 4 types of automation stages, and I mentioned earlier that for many buildings it's very basic, right? So, but a true smart building, there are 4 types of automation stages. The first one, which we see the most of, is data sensing and metering. And this is the most basic type of smart building. And it enables asset management, it enables tracking and predictive maintenance. And an example of that would be, is the firmware up to date on the heating systems? Is the light fixture on level 4 responding? So very basic. The next level down is real-time integration and historical data. So an example of that would be, are the water filters due for maintenance based on the number of hours in use? Or do we need to adjust the heating and cooling temperatures based on seasonal temperatures outside? So it's really combining data that we already have with what we know is happening within the building. And then we get to where we want to go with buildings, which is data modeling, analytics, and machine learning. So this is where we enable devices within buildings to actually act upon data collected and self-improve over time through local trained models. And this is key. And this is where we're going in the smart buildings world. And lastly, through visualization with a single pane of glass, we want to be able to offer how that building is performing to different audiences. For example, to building management operators and tenants. So these are the 4 stages where, for the most part, with smart buildings in the blue stage on the first stage, with our goal to really going through and creating a pure smart building by implementing the visualization stage. So why is this important? If we look today, smart buildings will need to be more intelligent over time. And with a gradual continuum from basic connected buildings through self-learning, we really want to be able to go through this continuum and enable buildings to be able to maximize its ability to take advantage of more intelligent technology. So on the left, again, basic, the basic implementation that's in place today, going towards the right, towards smart buildings, and then going to the absolute right, which is what we call cognitive buildings with AI/ML. So we're coming to the why, which is by 2025, so buildings will be the #1 consumer of energy today. And so it basically is, real estate is the 2nd largest expense of a budget or income statement. It's the 2nd largest expense. And while it's forecasted to be the #1 consumer of energy, up to 50% of that will be wasted, which has economic and environmental implications. So this means, the need for smart buildings is not only just for customer satisfaction, it's actually a requirement to understand how we better operationalize our buildings to cut costs. And the benefits, aside from cutting costs, right, because of the cost implications, the benefits to implementing solutions that drive operational inefficiencies are clear. So building management companies have seen energy usage reduced by up to 40%, and maintenance costs reduced on average by between 10 and 30%. And on the other end of the spectrum, providing customer satisfaction is key, with smarter buildings seeing on average, about 91% occupancy rates, and 65% of customers willing to make their workplace more environmentally friendly. So really, happy customers and improved efficiencies, with happy customers and improved efficiencies, the largest expense starts to experience a rise in productivity, which is key for building management companies moving forward. So we've spoken at a very high level about the continuum. We spoke at a high level around moving from a basic building to more of a cognitive and very smart building. So what are some of the use cases that we're seeing today? So it's ranging from, building automation of devices such as lights and white good appliances and TVs. So lights switch on and off. And then we go to security and monitoring use cases using thermostats and security cameras and with better effective video surveillance. And then we have really the underlying components, which is, how do we manage in a smart way our networks such as Wi-Fi's, routers and modems. So really these are the top 3 use cases we're seeing today, which is providing automation to our basic equipment in the building, providing automation around how we manage the networking, and providing automation for security and monitoring of key devices. And then
Lorraine,
we get to a second
Lorraine,
yes.
I think it's probably also interesting to think now when you look at all of these other endpoint devices, basically is everything now is IP addressable, all of these endpoints, that reinforces the need for a back-end infrastructure solution like AWS IoT capabilities who can capture all this information that previously wasn't part of your IP infrastructure.
Absolutely, and Ron, we'll come to that shortly. And this is key. It's highly complex. And the next 2 slides will show that So we showed one in the basic management, the basic devices. This one, the next set of use cases expand on that, on additional ways that we need to be managing smart buildings. for example, restaurants, garages, for example. And then we have the other component, which challenge that our customers are facing, and that all these devices you just mentioned, Ron, they all have different protocols and different ways to connect. And that's if they were able to connect before, because we're talking about legacy systems. And if you just take HVAC supports Modbus or BACnet. Energy and monitoring systems support Zigbee and Z-Wave. And so our customers have been really challenged to know how do they do that, right? How do they create a smart building? So coming to your point, Ron, about technology, right? So AWS actually provide a set of managed services that enable our customers to be able to build smart buildings. So it's a set of building blocks. So firstly, it's a set of building blocks that will allow your edge devices to be able to be cloud connectable, if I can say that, right? So we have operating systems that you can download and software that you can download to the edge. Okay, once you've downloaded the software to the edge and you've connected your device to the cloud, and that could be anything from a basic light bulb to a light switch to a camera. So really we're talking about any type of device, HVAC system. So we have the software that enables you to connect the devices. Then you want to be able to connect to cloud. So we have an underlying infrastructure that will store information about all your devices and be able to allow you to organize that. And we're going to talk about that shortly. And then lastly, we have the managed services that allow you to analyze that data. I'm just going to show you on the next slide how that looks physically, or not physically, but just really all of those components coming together. And if you look at the left, right, the left-hand side, we have all of the many different types of devices that's tied to your building. And then if you look at the key set of managed services moving as we go into the right, we have Amazon FreeRTOS, which is an operating system that can be installed on your devices, or an SDK. And that operating system or SDK allows you to connect your devices to the cloud. Or it allows you to connect it to what we call a gateway, green grass gateway. And this is key because before the customers would need to have done that programming themselves, would have had to try to understand with one protocol how would they allow devices to talk to each other or even to one place. So we do that for you. So once we've got that, then we'll come to the middle section, which is cloud, Amazon Cloud, and it connects to our platform, which is AWS IoT Core. And that allows you to be able to really take your building and organize it in a way, different floors, different rooms, even different organizations, so you can visually see all of the components, how they tie together. And then as you go towards the right, is to be able to define rules for that. So how is the heating on floor 2, right? Or floor 2 has not been used at all today, so we're going to turn the heating down and the lights, for example. So you are able to begin to collect information from the left, be able to connect that to cloud, be able to do an analytics on it, and really be able to act and adjust the building parameters accordingly, depending on the output. So let me just go in and Ron, does that answer the question?
Yep. I'm listening. I think this is right on track.
So let me just go in a little bit more detail around AWS IoT, because this is really pivotal around what that technology is. And I've said, from the previous diagram, it's a set of managed services, and it's pre-built that customers will be able to take and use to be able to create a smart building and meet smart building use cases. But why use it? So if we look at, I spoke about Amazon FreeRTOS. So Amazon FreeRTOS is an operating system for what we call microcontrollers, and it provides security and connectivity libraries in a tiny memory footprint. And the reason why I call that out is, if you can imagine, once upon a time, it seemed impossible to connect a light bulb to the cloud, and you can now. Now we can connect light switches and right through to the really huge HVAC systems that are in buildings today. So Amazon FreeRTOS is a game changer to be able to really think out of the box on how to create smart buildings. And then we have the very big question is, well, once we start to create smart buildings, is how do we really provide security for all of these devices that are now talking to cloud? So AWS IoT provides that end-to-end authentication and encryption of data, and code signing, and it actually allows you to do over-the-air updates. So if you imagine that we have 10,000 devices in a corporate building or a campus, for example, through our cloud mechanism, we can actually check that the firmware or the software is up to date, and if not, be able to automatically drive over-the-air updates, which is really critical. The more disparate and the more diverse these devices are across a building or a campus or even wider. Then we get to offline communication, or then we get to local communication. And I spoke about Greengrass. Now, Greengrass is a gateway, and what you'll find is the gateway is installed in every building. So, and actually, you might even install a gateway on every floor, depending on what your configuration looks like. So what it enables us to do is they can process and act on data locally to respond quickly to local events. So if we knew that an HVAC system was overheating, we could still do the round trip to the cloud, but we would likely want to react on that immediately. Same with smoke detection, same with gas, or really we want to be, there are certain scenarios where the connection to the cloud is fast, we want to be able to act on that locally. And having Greengrass gateways in every building or perhaps on every floor enables us to do that. And all Amazon FreeRTOS devices easily connect to Greengrass. And I spoke briefly about over-the-air updates, but really key for devices running on AWS Greengrass and Amazon FreeRTOS can be updated over the air for security updates, bug fixes, and new feature updates. Really critical, again, when you just consider a corporate building that might have 1,000 light bulbs and 1,000 light switches. The more automated we can do that, the better. And in a previous slide, I spoke about AWS IoT Core. That's a whole discussion in itself, but really it is a complete platform that allows you to easily connect your devices to cloud securely and at scale. And it's available globally and in major cities. So there isn't the concern around latency. You should be able to easily connect from devices to Greengrass and to the cloud and be able to send data to and from the cloud. We have device management, and I'm calling out device management for buildings especially, because if we look at maybe a corporate building, for example, you will have different floors, we will have different departments and organizations and different groupings, and device management is very key to be able to organize what we call the fleet in a certain way and be able to apply different rules to different organizational structures, and they have different visualization mechanisms as well. So device management is automatically part of IoT Core. And then we get to analytics. So we spoke about the more basic way of managing smart buildings. Now, and I mentioned on our very first slide, it isn't just about fixing problems, it's about creating a better infrastructure to manage costs and create a better customer experience. So the more insights we can gain from our building, the more we can tweak and improve on that. So out of the box again, we have AWS IoT Analytics, which collects all the data from all your devices, that goes through IoT Core. And with that, we can troubleshoot, but we can also perform predictive analytics on the data we collect. Allows you to visualize very quickly and gain really key insights that you can act on accordingly. And then let's go further. We spoke about going from basic management to something more that your building would be able to do. And once you have your devices connected to cloud, and you have that mechanism, and you've cloud enabled your building, then there are other use cases that would be much more easily implementable. So we have cameras that are green grass enabled. So basically, you can automatically install those cameras. They have Amazon free RTOS installed on them. They start filming straight away and can start streaming analytics, video surveillance data to the cloud. We have machine learning. So I spoke about analytics, but all that data that we collect for analytics can also be pushed to our machine learning services to be able to provide self-learning on the edge as well, and building surveillance, energy management. And this we're calling out in the sense that because Amazon is a set of building blocks, we're working with key partners who are experts in the field, for example, of energy management or waste management. They've automatically built their applications on top of AWS and can drive, and where you can implement immediately, and you can begin to drive solutions like managing your lights or managing waste, for example. And then even more into the future, get tied into Amazon AWS IoT, can very easily and quickly be able to install virtual assistants, and that's through a service that can be called from AWS IoT called Sumerian. And so imagine we've collected all that data. We have a visualization and understanding of how that building is functioning at that particular moment in time. And we could go in, we can say, hello, I need a room that has heating already for 12 people. And the Sumerian, the virtual assistant is aware of what's needed and is able to turn the lights on, ensure that you have the right equipment, and guide you to your room. So as an example, so for us, again, it's about improving the customer experience. Also, AWS IoT, we have integration with Alexa. And Alexa, again, it's using the same information that's gathered from all of the devices. So if you're able to ask Alexa, find me a free meeting room. And you can say, Alexa, turn the heating up. Alexa, for example, there's a lot that you can do because now Alexa is using the same information that you've collected from all those devices. And again, for us, it's about creating a better customer experience. And even more simply, we have a partnership with iDevices as an example of one of our partnerships. So it's Alexa enabled. So you can walk into a room and really say, Alexa, turn on the lights. And this voice-activated remote will actually turn on the lights for you as you go into a room. All of this is about not just smart buildings, about what breaks and what doesn't break. It's really about improving the customer experience. This slide here is really, it's the complete architecture that ties together all of these components that I've been talking about. And this is an IoT-enabled smart building. And while it seems like there's a lot of components to this, I want to stress that these components are pre-built. And to be able to enable them, you would go into the AWS IoT console and enable the managed services components that you need. From left to right, install RTOS on your devices, IoT enable them with our guidance, and then be able to drive that data through a gateway, which is AWS IoT Greengrass or Core, send all that data to cloud and to IoT analytics. And really, as we go to the right-hand side, is depending on the rule that you create and the data you collect and the analysis that you've done, you can call over 130 additional AWS services, which include, and I meant to just touch on it very briefly, which includes AI/ML services, video storage and analysis, data storage, dashboarding, for example, notifications. So there's a lot that's pre-built for you that you can leverage. So, when we go back to really that very first slide, I said if you had the data and understood the state of everything, what would you do? And when we bring that same question down to smart buildings, I've just spoke about the technology, really, and about some of the use cases. But really, this is about IoT enabling building management systems. So building management systems, a truly smart one is changing the building industry. It's changing the way that we are doing business as we go forward, especially as the Internet of Things continues to disrupt virtually every industry and traditional engineering approach. So with cheaper internet-connected sensors that can now be used to saturate a building, providing far more data points than ever before, connected to advanced cloud-based analytics that deliver superior performance, it's become much easier to create an IoT-enabled building management system than before. So as we just close out, our goal with AWS IoT for smart buildings is to create and enable these 4 business outcomes. So with BMS, with building management systems built on AWS IoT, building owners have now become empowered to own efficiency and sustainability of their own facilities. With the caveat that IoT is a critical enabler disruptor will help drive better business outcomes in a sustainable way. And thank you very much. And Ron, I'm not sure if you have any additional questions.
I thought that was fascinating. I was just mesmerized listening to your talk, Lorraine, because you can see all the power. I can think in some of my past professional roles working in the alarm and fire detection field, this was always the holy grail. It was always challenging to get everything to work together in a secure, cost-effective way. And it's amazing to see all the work that AWS has done in the back end to provide the foundation for organizations to be successful and finally achieve the benefits of the smart building. I think it's also relevant, and hopefully we'll get Lorraine or one of her colleagues to speak in the future, because you can also think a little bit outside the box, or like outside the building, and see how these same capabilities can be used outside of buildings, be it on smart cities or in transportation and logistics networks, et cetera, where again, there's just a wealth of data, and you basically need a company the size of AWS to spend, I don't know how many thousands or millions of man hours and dollars to put together the right platform. So then organizations, facilities, managers, IT directors can then know they've got the platform to think more strategically and not worry about how my thermostat can tie in with my IT network. I think it's just utterly fascinating and exciting, and will only get more relevant as this technology and widespread acceptance increases.
Yeah, and we learned something is smart cities, the build out of smart cities and transport and health and safety are really key, and most of our customers said, look, this is really important to us and we want to build it out. But firstly, help us understand how we can manage better what we have. And I should stress, and I think you touched on this just a moment ago, Ron, and reminded me, is that we're working with pretty much most of the manufacturers that provide the hardware for buildings. So we've already, and our goal is to just take away that effort of having to put FreeRTOS on these devices and having to test them out with cloud. So we work directly with the hardware providers to take that additional step away, in a good way, from the building management companies, so that they could focus on, okay, what rules do I want to apply and policies for when I do connect those devices and start collecting data. So our goal is to really make this as painless as possible, and taking best practice as well, and have our customers up and running as quickly as possible.
It's also interesting to look ahead in the future, and you could see how so many of AWS's business units, be it's, I don't know, billions of square feet of warehouses that are outside every major city, Whole Foods supermarkets, Amazon's own bookstores that don't have any checkout counter. They just track what you've bought by doing some kind of visual comparison of what the shelf looked like before and after. You can see all those capabilities are all coming together behind the scenes to offer these fantastic features to end users. Probably not unlike the birth of AWS itself, where Amazon had to build up a tremendous cloud infrastructure to support its original book selling business, and then offer those same capabilities to end users. And now you could see the same thing happening, whereby we built all these huge buildings, they have to be efficient. Now we want to offer those same kind of resources and features to third-party companies.
Absolutely. Well, and there's something even more pivotal here, I think, is in the new normal that we're facing now, is having a infrastructure in place, be it a city or a building or a campus or a factory with all of our facilities. An infrastructure is key so that when something like the COVID ID virus comes into play now, there is a need to respond quickly. And examples that we're looking at is how do we detect people's temperatures even, right? So there's, I think, this need to be able to implement an infrastructure so we can begin to respond quickly to events around us has become really front and foremost to our thinking as well.
Great. Well, I don't have anything else. I'm going to encourage everyone to continue to check back with AngelBeat. If you've got questions for Lorraine, you can go to our website, contact us, so we can absolutely get them answered. Please continue to use AngelBeat as a source of valuable, albeit digital information, as all of us are learning remotely. We hope to see everyone in the future. Just again, check back with angelbeat.com for the latest information, or hashtag AngelBeat on all social media for the latest information. Otherwise, I'm going to stop the webinar now. Thank you, Lorraine, very much. We're looking forward to seeing people in person, hopefully in the not too near future, maybe
Absolutely.
around the August timeframe. And please stay safe. And thank you all very much.
Yep, look
and
forward
thanks
to it.
especially, Lorraine.
Thank you, everybody. And Ron, thank you very much. And look forward to seeing you soon.
All right. Bye-bye now.
Bye-bye. Bye.